In today's webinar, I'm going to cover the new features that have been added to the Cogent DataHub version 8. The Cogent DataHub is an industry leader in secure networking technology. This new version focuses on expanding the DataHub's ability to connect to a wider variety of data sources using industry standards. We understand the growing need for you to share your data that originates on your operations network. Many people refer to this as the convergence of OT and IT. Experts predict that by 2019, about 35% of large multinational companies will be integrating their IT and OT systems at a significant level. The DataHub is already widely used for this, and we expect this particular usage to grow over the next few years. The entire presentation should only take about 30 to 40 minutes. I plan to briefly cover each of the new features and then do a live demo focusing on OPC UA and the camera support features. For OPC UA, I'll show you how to make the DataHub act as both an OPC UA client and server, as well as how to manage security certificates for OPC UA. For the camera demo, I will connect to a USB camera and show you how to both view and control the camera remotely. As I mentioned, the DataHub added the ability to act as both an OPC UA client and server. I wanted to give everyone a basic understanding of what OPC UA is so that we're all on the same page. OPC UA stands for Unified Architecture. This has been an ongoing effort since 1994 with the goal to create a new standard that's not dependent on DCOM, can interoperate with non-Windows platforms, and is more secure than OPC Classic. So why is OPC UA better? It really all comes back to removing the dependence of DCOM. Now, since OPC UA doesn't rely on DCOM, you can network OPC UA over the internet and through firewalls. It's also more secure. With DCOM security, you had to open up this security and relax it in order to establish a connection. This makes OPC Classic more vulnerable than OPC UA. OPC UA uses host identification and authorization, which we will learn about more on the next slide. OPC UA connections can also be SSL encrypted. Again, since DCOM is no longer used, this allows OPC UA to be both platform independent and reside directly on PLCs or other devices that can then act as their own OPC UA server. Security in OPC UA is all handled using certificates. A certificate is used to represent an OPC UA client or server. Both servers and clients keep a trust list to know which servers and clients can establish a connection. Let's see that here so that it will make more sense in the live demo. The client will request a connection to the server and send over its certificate. The server checks its list to see if that client is on the list and either accepts or rejects that connection. The server will also send a copy of its certificate to the client, which will then check its list to see if the server is on its trusted list. If both are in their respective trusted list, then a secure connection is established. We will do this in the live demo to show you how that's done. I want to offer some specific details on some of the features of the DataHub's OPC UA support. Managing the security certificates is likely the hardest part of establishing an OPC UA connection. We make it very easy to accept or reject certificates using our built-in management tool. On the same theme of ease of use, we wanted to make security options obvious and easy to use. We also have built-in diagnostics that you can run in case you're having problems establishing a connection. The DataHub will maintain the OPC UA data model and does not flatten it like some other OPC UA clients. And since the DataHub supports both OPC UA and OPC DA, both client and server, we can easily convert these two protocols seamlessly. Let's jump in and talk about the addition of camera support. Camera streams are being used more and more in manufacturing, but the problem is that they are inherently insecure. I'd like to give you a quick understanding of some of the security risks associated with cameras. Most cameras will require that the user log in to an onboard web interface in order to access the live video feed. Now, if that client wants to then access that data outside of the camera's network, they must open up a port in the firewall to allow access to this video feed. The Cogent DataHub version 8 offers networking of camera image data using our secure networking technology. This allows customers to share live camera streams across corporate and internet networks without exposing the plant network to attacks. The camera feature also allows you to remotely control all aspects of the image, such as quality, width, height, scale, aspect ratio. Basically, anything that the camera provides access to, we allow you to read and or write to these properties. Now, these points can also be tunneled and controlled securely remotely. I'll show you how to do that in the live demo. You can embed the video into web view pages or make it available to other image processing systems. In the DataHub, we treat images just like any other data point with equivalent security. Images are base 64 encoded and represent a data point in the DataHub and are accessible by anything that can consume a base 64 encoded image. The DataHub tunneling is our most popular feature and is used primarily to network data when DCOM configuration is not possible. Now that we offer DA and UA, you could connect locally to a DA server and tunnel that data over the network and expose it to UA clients. The unique thing about the DataHub tunneling is that it can tunnel any data that it can connect to. That includes Modbus, ODBC databases, OPC A&E, camera images, Excel, and more. Basically, anything that the DataHub can connect to, we can then tunnel it over the network and make it available on the client-side interface. So why would you use tunneling? With tunneling, you won't have problems with remote OPC calls being blocked since we connect locally to the connection, and also the local connection typically won't get dropped, at least not like a remote connection could. Now, if the network connection does break between the two data hubs, it's recognized within milliseconds and quickly recovers. Some OPC servers only allow a single client to connect, and then they charge a fee for additional clients. The DataHub can act as a single client to your server and then serve that data to any number of clients without additional licensing cost. With tunneling, we can provide access to your data on your operations network without having to open up inbound firewall ports. All of this was possible with version 7. Version 8 adds the ability to support HTTP Connect and basic proxy authentication. The DataHub is the only middleware product that allows you to tunnel data through network proxies without compromising corporate security. The last thing I want to talk about before we get into our live demo is the support of HTML5 when using our SkyHub cloud service. You can develop your web pages using the same way you've done in the past using your desktop browser and that supports Silverlight. Then you can upload the pages to the SkyHub cloud service where they will be automatically converted to HTML5. Anytime you make a change and save your page, the HTML5 version will also get updated. Because this is HTML5, these pages can be viewed from any device. These images here that I'm scrolling through are images that I took on my cell phone yesterday. these are just some of the examples of the pages that were made with the classic web view and then converted to HTML5 in the SkyHub Cloud Service. Our next step will be adding HTML5 support for local web view installations, but at this time I don't have a timetable for when that support will be added. All right, let's get right into the live demo. I told you that was going to be short. I hate death by PowerPoint. There we go. First thing I'm going to do is grab my DataHub and bring it over so you guys can see it. Okay, perfect. So the first thing I want to show you is how to establish an OPC UA connection. Now, because I want to establish a remote OPC UA connection, I'm actually going to start by connecting locally to a OPC DA server, and then I will tunnel that data over to a remote machine, which you'll see here. This is my remote machine that will actually act as an OPC UA client to this DataHub, which will be the OPC UA server, okay? So let's get started. We need to start by establishing a connection to my OPC DA server. So if I pull down my drop-down, I can see a list of all the servers I have. I'm going to connect to the top server, call this top server. I'll do a read rate of 1 second, and I'm going to load all the items on the server because I don't have a, I have a couple hundred items. So, if you have hundreds of thousands of items or even tens of thousands of items, you might want to load, or excuse me, manually select the items. Okay, let's click OK here, and we can see it's configuring. If we click the Apply button, it will establish a connection. Okay, so we got that done. Now we're connected to our DA server. We can see here, let's just verify that we have good quality data and the data is changing. That's what we'd expect. Now, this DataHub here is going to act as a UA server, okay? So we don't need to do anything else on this DataHub. What I can do now is bring this over here. I'm actually going to make this full screen so it's easier to read. And the first thing we're going to do is establish a UA client connection to my UA server. So if I click Add, the discovery domain, that's really just the computer that you're trying to connect to. 008 is my laptop. And if I use the drop-down, it's discovered 3 different ways we can connect via UA to my DataHub. I'm going to connect using the first option. The first way I want to connect is using no security to show you how easy it can be to insecurely connect to UA clients. There's no DCOM, there's no configuration. If we test the connection, it should just work. And in this case, we have OKs across the board. That means it will work. Click OK here, click OK here. Actually, we need to load all the nodes on the server. Sorry about that. Click OK and apply. We can see that the status went to running immediately, which means we do have a connection to that data. If I look here, here's all my data from my remote connection. If I expand, let me make this bigger here. If I expand this, you can see that same data changing. Okay, so we've easily made an insecure UA connection. Okay, great. How can we secure that connection? That's the next step. So first thing we want to do is we're going to use the security policy of basic 128, and we're going to use the token type of my certificate. Now, when I test this connection, it shouldn't work, and that's because both the client and the server don't know about each other's certificates yet. So let's just test it. The first thing that just happened was we were returned from the server, which is the DataHub running on my machine, this DataHub right here, sent its security certificate to this remote DataHub. It says it's untrusted. The reason is it's a self-signed certificate, so we're going to accept that certificate. At this point, the client has accepted the server certificate, but the server has not accepted the client certificate. So you can see we've still failed the connection, okay? I'm going to just minimize this so it's obvious where we are. If we go here, you can see we have a rejected certificate. So the client has shared its certificate with DataHub, but DataHub by default is secure and will not just accept any certificate. If we go to Manage Certificates, you can see here, this is the computer that I'm wanting to connect to. So what I'll do is I'll just accept that, okay? Now, if I go back to my DataHub and start the test again, the test succeeded. So we should be all set. If we could click OK, click Apply, it's going to disconnect and reconnect in a secure fashion. So now that we're running again, let's click View Data. Of course, we should see the data changing again, which we do. Nice and easy. Now, I'm going to undo those security certificates. Before I do that, I want to uncheck this. Perfect. Go to Manage Certificates. Let's find the certificate for my laptop, and we're going to remove it. Okay. On the same token, we're going to go to the DataHub UA server side and manage the certificate. Find the one for this machine here, and we're going to delete it. Okay. There is another option for how to make a secure connection that's easier, especially if you have multiple clients or servers that you're trying to connect to. So let's show you that. On the server side, if we go to Advanced, let me move this over so you can see. There is a checkbox that says Automatically Accept Untrusted Certificates. Let's do that. We're going to accept the warning. We don't want to keep this on forever. This is something we're going to use while establishing the connection and exchanging the certificates, and then we're going to turn it back off again. So if we click OK, we also need to click Apply. Now let's maximize this, and we will go to this configuration here. I'm going to reject this for now, and I'll tell you why. I wanted to also check this box here that says Always Accept Invalid Server Certificates, okay? So let's do that. Let's go to Manage, and let's delete this rejected certificate, okay? Because I want this to go from scratch. So if we click on and hit Apply, notice the connection went to running. We didn't have to accept anything on this side. If we go to Manage Certificates and we check, we have my laptop's security certificate. Now, on the other side, on the server side, we see here we have a temporary certificate. Temporary certificates are deleted out of the temporary certificate store when the DataHub stops. So we need to either accept this now or expect that it will happen again next time. So in this case, we're going to accept it. Yes. And if we go and manage it, we can now see that in my private certificates, that certificate's back. And that's what we wanted. Now, you could connect as many clients as you wanted to this DataHub server, accept all of their temporary certificates, and then the last thing you got to do is go back and uncheck the Automatically Accept Untrusted Certs, click Apply, and we will want to do the same thing on this end as well. So Edit, OK, Apply. That's it. So in this OPC UA demo, I've showed you how to establish an insecure connection using DataHub UA. And then I showed you two methods on how to create a secure connection. One is more of the manual way of accepting certificates. And then the second is automatically accepting them and then removing that security vulnerability once you've got everything configured and working the way you want it. Either method is completely acceptable. So again, we wanted to make the certificate management the easiest part of this process, since that can be quite difficult sometimes. Okay, well, we're done with the UA stuff. I want to show you the new camera support. So Let's get this out of the way for now. And what we're going to do is we're going to add a new camera connection. So I have two cameras. I have an integrated camera on my laptop as well as a camera that's facing outside here. I'm going to set the resolution, something in the middle. We want to do two things. We need the image because we're going to tunnel that data and use it in WebView. And second, we want to be able to enable or disable the camera remotely. Now, if your camera supports these other features, then you can check all these boxes, make them writable, and then control the camera remotely, which can be done. These are all accessible as data points at that point. We need to put this in the camera domain, and we're going to prefix this with outside. So if you have multiple cameras, you could put them all in the same domain or different domains. Really, domain is just a way to group the data, but this prefix is yet another way to group the data. So if we click OK, we then want to turn the camera on, click Apply, and if we look at the view data, we should see that it's updating rapidly. This is the base 64 data point that is showing the image. Now, we also have a way to test the image. If we open it up here, you can see we have cars driving by, and this is the shot from outside my office window. And we're right next to the post office, so you might see multiple mail trucks, okay? So let's move this here. Now, the next step that we want to do is I actually want to tunnel this data to that other remote machine and then display it in WebView. So let's see if we can put this here, grab our connection to our remote desktop session here. And I'm actually going to make this full screen so that it's easier to read. So when establishing a tunnel, we want to add a master. The master is just my computer. I know the IP address is 192.168.111.60. The data domain that we are tunneling is called camera. And we don't need to use usernames and passwords, although we could. In this case, I'm just going to leave everything else at the default settings. Click OK, click Apply, and let's just check that we have this data working. So, looks like the image is updating rapidly like I'd expect. So far, so good, okay? Now, I also am acting as a web server here so that we can actually pull up a web page that shows this camera. Let's maximize this. I'm going to log in with the default admin username and password. And I've created a page. I will also show you how to create this page once we get to that. So you can see here we have the camera is working just great, and it's in WebView, and I'll show you how I created this page here in a second. Now, we can disable the camera. So if I uncheck this box here, see that car driving by? Oh, we just turned it off. I need to put it in run mode. Oops. Put in run mode, and let's click the box. Luckily, it's windy today, so we should be able to see the camera image freeze, okay? The reason why it freezes is because the data point still exists here, right? The data point is in this camera thing, and it's holding the last known value for the image. So if you wanted to, say, make it a blank image or something else, we have ways to accomplish that and maybe show that the camera's off. So, but in this case, I just made a simple demo where we just freeze the camera. We can then enable the camera again. We can see that this car is just pulling up here. And if we go back, we obviously see that the image is updating, okay? I mean, the same thing can be done from any HMI. So you could write this value of 0. Hopefully you can tell the camera image has stopped updating. Let's enable it again. And since this data point is writable from any OPC client, we can write to it from anywhere, right, to enable, disable the camera. That goes with all the other features of controlling the camera as well. Let's stop this, and I'm just going to create a new page. Okay, let's add a control, and we're going to go to the media controls. We're going to add an image. make this a little bit bigger. And what we want to do is do a binding, a point binding in this case, to the image data. The image is called camera:outside.image. That's it. Nice and easy. Now we've bound the image to this, this point to this image. Okay. Now the second thing we can do is we can grab a input controls and we can go with a simple checkbox. Pull it down here, and we want to do a point binding to the value. And in this case, we do camera again. It will populate the different options we have, and we just want to use the is enabled. If we click play and uncheck that, you can see that car got stuck behind that bush here, and the camera is stopped again. Okay? So pretty easy to quickly make a web page that displays this data. Oh, my camera has officially fallen off the wall. Well, that's okay. Let's stop the camera, and we're done with the demo anyway, so guess I should use better tape next time. Okay, well, hopefully in this demo you saw how to both make a connection to the camera, tunnel that data across the network, and then expose that into the web view. Now, given that this data from the camera here is just a base 64 encoded image, any HMI or image processing system that can accept that type of image can accept this data point and display the camera. Now, with that said, let me stop my sharing and open up the floor for some questions and answers here.